Let's start. Okay, let me join first. Yes, let wait for 5 minutes and let everyone join. Then we will start. Okay. Okay. Let me share my screen and let me know is this visible to you or not. Okay. So in last class we have discussed about laminar flow and turbulent flow, isn't it? So as you know, laminar flow is also called viscous flow. So today we are going to start a new topic related to laminar flow, and that is laminar flow between two parallel fixed plates. Okay, let's see how flow characteristics, different flow behavior will change if we consider two parallel plates for a laminar flow. Okay. So let's start today's class. I think everyone has joined, isn't it? No one is left. So let's start. My screen is visible to you? Okay. So today we are going to start laminar flow between two parallel which are fixed and separated by some distance. Yes, this is the name of the topic, name of today's class, topic name, laminar flow between two parallel plates, or laminar flow through two parallel plates. Okay, all of you note it down. Whatever I have given, whatever I have shared to you, you just note it down. Okay, otherwise in exam time it may create some confusion. Let me share my screen. Is this visible to all of you? Okay. Okay, so flow of viscous fluid between two parallel plates. As we know, viscous fluid is also known as laminar flow. Okay, laminar flow. So here in this diagram you can see two plates which are parallelly placed, and these two plates are separated by some distance. Let's consider that two fixed plates are separated by a distance t, small t, okay? And the direction of fluid flow is from left to right, okay? The fluid is flowing from left to right. You can see the direction of flow is showing here. It is from left to right, and the distance between the two plates is t, small t. Okay. So let us consider a fluid element A, B, C, D. We have to derive some equations by taking a fluid element only, not the whole fluid. We cannot taken the whole fluid, okay? That's why we consider a small element of fluid, and it is named as A, B, C, D. The length of the fluid element is given as del x, and width of the fluid element is given as dy, okay? Dx and dy. And suppose here what will happen? On the fluid element, 4 different forces will occur, okay? On the fluid element, on the faces of fluid element, 4 different types of forces will act. These are pressure forces and shear force. Pressure force on wall AB and DC, and shear force on the wall BC and AD, okay? So the pressure force which is acting on the wall AB is given by P into dy into 1. As you know, pressure is the force divided by area, force per unit area. So force equal to pressure into area. So pressure is P is the pressure, and dy into 1 is the area of the fluid element in x-axis direction, okay? So pressure force acting on wall AB is P into dy into 1. Again, pressure force which is acting on the wall, DC is P plus del P by del x into dx whole into dx into 1. And here what will happen? The direction of flow is opposite to the direction of fluid flow, isn't it? So this force will be taken as negative, okay? So forces occur on the wall DC is P plus del P by del x dx whole into dy into 1, okay? Again, if we talk about the shear stress, so I think shear stress, all of you know what is shear stress, isn't it? What is shear stress? Force per unit area. So shear force will be shear stress into area. Okay, so using that equation we have to find out the shear forces which are acting on the wall AD and BC on the fluid element. So the the shear force acting on the wall BC will be shear stress into area, and shear stress will be given by tau into area, dx into 1 is the area. So this will be the shear force acting on the wall BC. Again, the forces which are acting on the wall AD, it will be tau plus del z by del y into del y whole into del x into 1. Okay? Yes. Pressure force, already P equal to force per unit area. So pressure force will be pressure into area. So pressure is given by P into P. Pressure is given by P and area is given by dy into 1. So pressure force will be P into dy into 1. Okay? Is that clear to you? Okay, so did you get my point? What I have said? There will be 4 forces: pressure forces on the wall AB, pressure forces on the wall F on the face CD, shear force on the face BC, and the shear force on the face AD. Okay, so these are the forces which will act on 4 wall of the fluid element. Is it clear to you? Okay, so what will happen if these forces will act on the element? The resultant of the force will be 0 because there will be no acceleration in the direction of flow, and we know for steady and laminar flow there is steady and uniform flow, there is no acceleration. So the resultant of the forces will be 0. Okay, so we can consider that the resultant of the 4 forces will be summation of 4 forces will be 0, which I am going to show you in next slide. Note down, everyone. The diagram should be proper to you, and it should be thorough. Okay, if you don't understand the diagram properly, then you don't understand for the upcoming equations also. This is the shear forces which occurs on the wall AD tau plus del tau by dy into dy whole into dx into 1. And in the on the face BC, it will be shear force will be tau into del x into 1. Resultant of the four forces will be 0. So the equation will be like okay. Up to this everything is clear, or you have any doubt? If anyone have any doubt about this diagram and whatever I have discussed, you can ask me. Okay. Okay, what will happen for steady and uniform flow? Acceleration is 0 and net force F will be 0. That is mass into acceleration equal to 0. In this equation, the acceleration is 0, so net force, the resultant force will be 0. So the equation becomes P into del y into 1 minus. Why it is minus? Because this force is acting opposite to the direction of flow. P plus del P by dx into dx whole into del y into 1 minus tau into del x into 1 plus tau del z by del y into del x into 1 equal to 0. Okay, so the negative sign indicates that the direction is opposite to the direction of flow. Let's here two negative forces is here. One is the pressure force which is acting on the wall AD and DC, and another is shear stress which is acting on the wall BC. Okay, so if you solve this equation, if you break all the brackets, if you multiply all the terms, some terms will be cancelled, and then you will get minus del P by del x into del y plus del tau divided by del y, del x del y equal to 0. After that, ultimately you will get del P by del x equal to del z by del y. Okay, so you can mark that equation as equation number 1. So using that equation, we are going to find out some deductions. These are velocity distribution along the plates, shear stress distribution along the plates, and maximum to minimum, maximum velocity, ratio of maximum velocity to average velocity of the plate, and drop of pressure in between two sections of the plate at any length. Okay, so these things we have to find out using this equation, del P by del X equal to del tau by del Y. First of all, we will find velocity distribution along the plate. So, how velocity will be distributed, we will know in our next slide. So, after this, everything is clear. Okay, let me share next screen. Wait for a minute. Let me arrange my screens. Yes, so we will come to velocity distribution. So let's see how can we find velocity distribution. I think all of you know about Newton's law of viscosity, isn't it? So what is Newton's law of viscosity say? According to Newton's law of viscosity, it is generally related to shear stress and Okay, so according to Newton's law, we have shear stress equal to mu del U by del Y, or mu is the dynamic viscosity. Okay, so shear stress is directly proportional to viscosity. So tau equal to del U by U del U by mu del U by del Y. So what we have to do, we have from equation 1 del P by del X equal to del tau by del Y, isn't it? So in equation 1, in place of tau, you just put this value. After that, what will you get? After putting this value, you will get that yes, so after putting value, you will get del P by del X equal to del of mu into del U by del Y into del Y, and you just multiply del square U, mu will become first mu into del square U by del Y square, and if you take del square U by del Y square in left hand side, then it will be del square U by del Y square equal to 1 minus mu del P by del X. Okay, so after that we have to integrate this equation. So after integration, you will get del U by del Y equal to 1 minus mu del P by del X Y plus C1. Okay, one constant will come after this equation. So the equation after integration becomes del U by del Y equal to 1 minus mu del p by del x y plus c1. So if you integrate again, if you integrate this equation again, then you will have the velocity equation as u equal to 1 minus mu del p by del x y square divided by 2 plus c1 y plus c2. Mark this equation as equation number 2. So velocity value u is, where u is the velocity, u will be 1 minus mu del p by del x y square divided by 2 plus c1 y plus c2. Okay. So we have u equal to 1 minus mu del p by del x y square divided by 2 plus c1 y plus c2. Okay. So to find out this, if you integrate this again, another constant will come, c2. Okay, so we have to find out this c1 and c2. The value of these two constants we have to find out. For that purpose, we have to consider two boundary equations. These boundary conditions are y equal to 0, u equal to 0, and y equal to t, u equal to 0. So two conditions we have to consider to find out these two constants. First condition is u equal to 0. That means if y equal to 0, what is y? Y is the distance of the element from the lower plate. Okay, the fluid element we have considered, isn't it, A, B, C, D? So we assume that that fluid element is situated at a distance y from the lower fixed plate. So the boundary condition will be if y equal to 0, u equal to 0. That means velocity will be 0. Again, next condition will be at y equal to t. That means if the distance of the fluid element is situated, the fluid element is considered at the upper plane, if y equal to t, okay, then u equal to 0. So these two boundary conditions we have to consider. So is this clear to you? Okay. Yes, the shear stress is given by this equation. Tau equal to mu del u by del y. I am repeating it again. Consider this equation, and using equation 1, del p by del x equal to del tau by del y, in place of tau you just put this equation. Okay, then you will get, after double integration, ultimately you will get the velocity equation as u equal to 1 by mu del p by del x y square divided by 2 plus c1 y plus c2. Yes, we put this equation in equation number 1, which we have got in previous slides. Okay, in previous discussion I have told you that we have got one equation, isn't it? By calculating all the net forces, the resultant forces, that equation is considered as equation 1, and put the value of tau in that equation, and ultimately after calculation you will get After double integration, you will get the velocity equation. Is that clear? Let's try to understand the calculations. Clear? Yes, we have taken that from Newton's law of viscosity. Let's move to the next slide. Yes, after double integration, you will get there will be two constants, C1 and C2. Two constant will come after integrating again the above equation. You will get, yes. So what we have to do, we have to consider some boundary equations to find out C1 and C2. Okay, so how can you find out the value of C1 and C2? We have to take two boundary condition, as I have told earlier. Boundary condition number 1, u equal to 0, y equal to 0. Boundary condition number 2, y equal to t, u equal to 0. Yes, let me share my next slide. Yes, so we are going to apply the boundary conditions. In the first condition, you have to consider y equal to 0 and u equal to 0. So put the value of y equal to 0 and u equal to 0 in this equation, and ultimately what will happen? What will be the value of C2? Calculate yourself, all of you. Calculate yourself and let me know what value have you got. So if you put y equal to 0 or u equal to 0, the C2 value will be 0. Yes, C2 will be 0. And in the second conditions, if you put y equal to t and u equal to 0, then your equation will be 0 equal to 1 by mu del p by del x t square divided by 2 plus c1 t. Okay, so solve this equation and ultimately you will get c1 value as -1, because c1 will be come to the left side and this will one negative sign will come in the right hand side, so it will be c1 equal to -1 by 2 mu del p by del x t. Yes, c2 you have got, c2 is equal to 0. Yes, c2 value will be 0. And then you have to consider the second boundary conditions, where you have to find out the c1 value. So c1 value will be c1, if you put in the above equation, just substitute these values in the above equation, solve it, then ultimately we will get the c1 value. So after getting these two values, c1 and c2, you have to substitute the values of c1 and c2 in the above equation. Okay, so if you substitute the value of c1 and c2 in above equation, what will happen? What will be the ultimate result? Substituting c1 and c2 value, your above equation, your velocity equation will be u equal to 1 by 2 mu del p by del x y square plus y into -1 by 2 mu del p by del x into t. If you calculate it further, then you will get u as -1 by 2 mu del p by del x into ty minus y square. Mark this equation as equation number 3. So substituting c1 and c2 value, your velocity equation becomes u equal to -1 by 2 mu del p by del x into ty minus y square. Okay, so ultimately you have got equation 3. Mark that equation as equation number 3. U equal to -1 by 2 mu del p by del x into ty minus y square. Okay, now we are going to discuss some interesting facts, that is velocity distribution and after that shear stress distribution. So the diagram will be, see, what you have got in the equation 3, that equation is similar to the equation of a parabola. What is the equation of a parabola? Yes, so the above equation is resembles with the equation of parabola. So we will discuss about velocity distribution in the next class. Now all of you write down your enrollment IDs so that I can click and I can upload it in the ERP. Okay, so everyone write your enrollment IDs. I will discuss in the next class about what I have said. Okay, so just write down your roll numbers, enrollment numbers. Yes, 114, 60, 101. Anyone left? Don't forget to put your enrollment IDs, otherwise it will be marked as absent. Okay, so I will share the next class link shortly. All of you join again at most probably at 10:15. Okay, I will share this link for today's second class. Okay, so thank you everyone. Yes, anyone left? Okay, no problem.